This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hello everyone, this is Felienne for Software Engineering Radio. Today with me on the show, Dr. Hadley Wickham. He is the chief scientist at RStudio, the leading IDE for R, and he's also an adjunct professor of statistics at the University of Auckland, Stanford University, and Rice University. He is the creator of the topic of today's show, the Tidyverse package, which supports tidy data approach to data import, analysis, and modeling in R. Welcome to the show, Hadley.
Hi, Felienne. Thanks for having me.
So, first up, what is R? Most of our listeners are programmers, but not statisticians, so they might have heard of R as a programming language, but what is R? What makes it unique?
R is a programming language that was designed specifically for the needs of statistics and data analysis. So it's been around for a while now. It's kind of the successor to a programming language called S that was invented at AT&T in the 70s, I think, late 70s, early 80s. And it was sort of originally designed to string together a bunch of C and Fortran scripts on the command line. But since then, it's really grown to become this environment for really fluid and fluent data analysis and exploration.
So you say that it's a programming language that has specific features for statistics. Can you give an example of what is a feature that someone doing stats really needs in a programming language?
So one thing that's really kind of basic and fundamental is this idea of a missing value. So, often you collect data and something goes wrong and you don't know what a specific value is, and you need some way to record that. And that's the idea of a missing value. It's kind of like a null in SQL if you've used that, but very, very few programming languages have that kind of built in at a fundamental level. Like most of them, like Python and Julia, kind of have it added at a higher level in the stack. The other thing, just in general, is that R was really designed from kind of day one to be this interactive development environment. So even more than like a scripting language like Python, the fundamental way you use R is you type, like a line or a couple of lines of code, and then you look at the output, and then you think a little bit, and then you type some more code. So it's a very, very interactive environment.
So that's a little bit like what you might know from other programming languages as a REPL, or is it something different?
Exactly.
So do we know how popular R is? Because I hear this, R is a very popular language for data analysis. Do we have a sense of how many users there are?
I mean, it's really, really hard to tell. I think multiple millions, certainly. And then it's kind of a matter of like picking the programming language ranking that gives your favorite programming language the highest possible ranking. I think it's fair to say, kind of looking across a bunch of different rankings, R is one of the top 20 most popular programming languages. I think it's, some of them show it in the top 10, but I think it's up there. It's pretty popular. It's mainly used for by people doing data analysis. So it's a little bit of a niche language. Like it is a general purpose programming language in the sense that you can do anything with it, but it is primarily used by people doing data science and statistics.
Do you also think that that's the way it should be, that people doing data analysis have their own programming languages, even though they might be also usable for general purpose? Is that a good idea? Or would it be nicer if everyone used the same language?
Yeah, I think it would be nice. It would be nice if there was like one programming language, right? That would be wonderful. Like you wouldn't have to have the same things developed multiple times with different programming languages. But of course, the problem is like one programming language can't possibly solve every problem completely in the way that you want it. Like if you have just one programming language, you've got to make a bunch of compromises. And I think you'd end up with a system where like probably no one is that happy with it. So there's certainly downsides to having like this kind of niche language specifically for pretty broad domain. But I think that the advantages of that, you get something that's really tightly tailored to the types of problems that you care about as a data scientist or a statistician.
Yeah, that makes sense. And R has been around for quite a long time. Do you think R is moving more away from being a general purpose language, or is it adapting features to look more like a general purpose language?
That's an interesting question. I think it's not the language so much that's changing as the community and what the community is developing. When I started using R during my PhD, which was like 15 years ago or something, R was almost exclusively used by people with PhDs in statistics. And it was very, very tightly connected to doing data analysis. And so not much has changed about the language since then, but the community has really exploded. And in the last 15 years, the kind of use cases and the things that people are using it for and what they need to do their jobs is greatly expanded. And so that kind of means things like for connecting to new types of databases and connecting to all sorts of the web APIs where people get data from these days. And that's just kind of meant that its strength as a programming language have kind of expanded in new areas that wasn't useful previously.
So then I want to zoom in a little bit about one specific part of R, and that's the Tidyverse that you created and designed.
Yeah.
Why did you make the Tidyverse? What problem does it solve within the problems that are already solved?
I mean, it solves a very similar set of problems. I think the thing that is kind of interesting and weird about the Tidyverse is in some sense it actually like restrains what you can do. It kind of constrains you, it constricts you, it gives you like a smaller set of options powered by some kind of like underlying theory designed around the idea of like really about composition. And in some sense, I think the Tidyverse is like a search for like the atoms of data science and like how and a simple set of techniques for combining those atoms up into molecules so you can like solve any problem, hopefully using this like pretty small set of fundamental ideas and fundamental techniques.
Did you make Tidyverse for your own use, or was it from the start already meant as something to serve the community?
So it really got started like well before it was called the Tidyverse when I was doing my PhD. And as part of my PhD, my assistantship was a consulting assistantship. So I helped PhD students help do the analyses for their PhDs, non-statistics PhD students. And that was really a transformative experience for me because I was doing my PhD in statistics at the time, taking all of these classes about, all these like really complicated mathematical theory and sophisticated models. But when it came time to actually like help people do their data analysis, the first problem you encounter is like, how the heck do you get the data out of whatever form they've stored it in? And, people collect data and record data in a way that makes sense, that makes it the easiest possible to record the data, not to analyze the data. And so the first problem you always hit in every data analysis is like, how the heck do you get it from the form they have it in into the form that you need it in? And that's really what started my journey into sort of the ideas of tidy data and tidying data and reshaping data. Like just how could I do my job with these data sets that I'd never seen before, stored in ways that frankly at the time seemed utterly crazy to me.
So what are the challenges, you would say, to create a programming language for statisticians? I think one of the challenges you just said is, well, data comes in any format, so we have to make it fit. That's probably also where the feature of null values comes in handy, that sometimes you have data in a messy format. But what other challenges are there if you're designing a programming system that's made for what we programmers would call non-programmers, people that aren't employed as professional programmers?
Yeah, I think it's really interesting to contemplate that. And that's something we spend quite a lot of time thinking about in the Tidyverse, kind of trying to balance, like, how do we give, like, experts, people have decided to want to learn how to master R as a programming language and get really good at it versus the kind of casual users of R who certainly don't identify as programmers. They just want to do, like, the smallest possible amount of R code to get their jobs done. And so I think like one of the things I really believe in is if you're not going to become a programmer, if you're not going to devote hours and hours to learning a programming language, it's really important to figure out what's the smallest set of big ideas you need to kind of get into your head. Most programming languages, those are ideas around like how functions work and how objects work. But in R, I think one of the big ideas is like, how does data work? And this idea that we've worked on of like tidy data, like how should you organize your data so that it's going to be easy to analyze after the fact? And I think like now I can kind of explain it in a sentence. It took like 10 years to get there. But the basic idea is that you want every column in your rectangular data frame to be a variable. And if you kind of look more at the theory of tidy data, you can see it has some pretty close parallels to Codd's third normal form. But just like this idea, like trying to figure out like what is this key idea and how can we express it succinctly in a way that like most people can understand with like a relatively small amount of training. That's something we spend a lot of time thinking about.
I think we might want to go one step back there because you did mention a few things that not everyone in the audience might be familiar with. For example, you said a rectangular data frame has columns within it. Could you elaborate a little bit more on what that means?
The main type of data that people work with in R is like rectangular data. So you've got rows and columns. And generally, in most cases, I think, to make data analysis easy, you want each column to be a variable, something that you've measured, and each row should be an observation, a collection of related measurements. It turns out to be really difficult to precisely describe like what a variable is and what an observation is. But generally, your kind of like everyday language, the everyday knowledge people have of variables and observations tends to be pretty good at once they've got that framework to organize their data in that rectangular way.
Yeah, so can we give an example of an observation and an example of a variable? Because I think variable means something slightly different here than it means for professional programmers in a programming language.
I always forget about all these different. This is, I think, one of the challenges of teaching, and particularly kind of interdisciplinary work, is all of these words that mean like totally different things to different people.
Yeah.
And before I talk about what I think a data scientist thinks of as a variable, statisticians have this idea of a random variable, which is even like something even worse because it's not a random variable, is actually just like a function. It's neither random nor variable, which seems like a really confusing name, and is again totally different to how you think about a variable in most programming languages. So a variable in a kind of data science sense is something like you measure, like weight or height or age or someone's name or like a unique identifier. These are like the columns you'd have in a database, like collections of measurements, basically, that are related by these observations. So an observation could be a person, it could be a person at a specific time, a person at a specific time given a specific drug to try out some new therapy.
Okay, I think that is clear. So now the concepts from statistics are a little bit more related to databases and things programmers might know. You said something really interesting. You said that you want a Tidyverse to have a small set of big ideas, which I think is a great way to design something. And I think we covered one of those big ideas, like a data frame and how do you organize your data.
Yeah.
Were there any other big ideas in your design?
So I think another big idea is this idea of tidy evaluation, which I think the way to understand tidy evaluation, if I can explain it briefly, is this kind of blurring of this line between a variable in this kind of like data science, statistical sense, like something, one of those columns in the data frame, and a variable in the computer science sense, something like that exists and you can work with directly. This is the reason why you want to blur this line is because you often want to do similar operations to these like statistics variables as you do to these computer science variables. Like you want to be able to say, I want to compute someone's BMI by dividing their weight by their height squared, for example. Now you're kind of combining those two ideas of variables. You're now saying, I want to create a new column, a new variable that is a function of two existing variables. And another thing that's interesting about R, which I haven't mentioned, in most programming languages, you'd have to, if you had multiple observations, if you had the weight and height for multiple people, you would have to write a for loop so that you'd loop over every single person, get their weight, square their height, and divide the two. Whereas in R, you'd express that in a single calculation because R is vectorized. So rather than just dealing with single numbers, it deals with vectors or arrays of numbers, so that you would just, to compute the BMI of any number of people, you just say weight divided by height squared.
And then it's automatically applied to all the observations that you have.
Exactly.
That brings me to another interesting question. What about scalability and performance? Is this something you look at the programming language level? Because I can imagine that you define a simple function and then you might not realize that this has been calculated over everything in your data set.
Right.
Do you help people write efficient code? Is your own engine really efficient?
Yeah, so I think in general, for myself personally at least, I spend most of my time kind of thinking about the efficiency of the human. Like most people are dealing with like data sets that are like small enough that the computational cost isn't the bottleneck. The thing that you spend most of your time doing is thinking about what do you need to do next with your data, and then how do you express that in R code. So, computational, the cost is certainly important, but it's something that I think I generally spend like less. That's sort of not my area of expertise. I care about like how do we make the human as efficient as possible. That means for like me as a developer of R packages, I spend some time rewriting my R code into C and C++ for efficiency and doing profiling and all the sorts of things that programmers do in every language to make their code fast. But by and large, like that's not something that most R users have to worry about because, again, they're not programmers. And they're dealing with, maybe tens or hundreds of thousands of observations, and just doing the most naive thing with modern computers is fast enough.
Yeah, so you say performance issues is not really something that you typically run into if you're doing data analysis.
I mean, that's a little bit strong. You probably still run into it a little bit, but it's not the thing that I think like dominates. Most of the problems are like figuring out like what do you actually want to do. You spend like minutes, hours, days thinking about that, whereas the computation might be seconds or minutes.
So we want to zoom in a little bit more into the design decisions that went into making the Tidyverse. And we talked about these big ideas, but I'm sure at one point there were also trade-offs where you wanted to have two features, but you couldn't have them both, or one new language feature impacted another language feature. Can you give us an example of difficult trade-offs that you had to make in the design process?
Yeah, I think the most common trade-off we kind of battle with is this tension between like experts and casual users of R. And because we, as the developer of the packages, like, we live in R, we're thinking about R 40 hours a week. It's very easy to kind of develop features that, make us super effective, but no one else can really understand how they work. There's been a couple of kind of recent examples of that come to mind. The first of this is the sort of idea of tidy evaluation, which I talked about briefly before, where like we came up with this like really good underlying theory, and we got really excited about it. And then we wanted to share it with the world. And frankly, the world was not ready for it, and the world did not really care about it because it was this really sort of advanced feature that we got excited about, but most R developers didn't need to. The other thing that's come up recently comes back to this idea of vectorization. Like you want to do something to every observation without having to write some kind of for loop. And R is a bunch of these vectorized operations built in, like all of the basic mathematics, if you want to add or divide or multiply, trigonometry functions, exponentials, logs, all of that's kind of built in. But sometimes you get to a point where you have a function that's not vectorized. And so how do you apply that to every single observation with something more complicated? Like maybe you want to fit a model, or maybe your variable is a list of file paths. And now you want to go through every file path that's a CSV file and read them all into one giant file. We've always I think we kind of keep bouncing back and forth in some sense between like explicitness and magic. And like on the explicit side is like teaching people about functional programming, because R is a functional programming language. Like how do you understand the ideas behind functional programming so you can use it effectively, versus like how do we just give you some magic so you don't need to care about what's going on behind the scenes. You don't have to learn anything about like functions or functions that work with functions, and you can just kind of do what you want. And so recently, in the latest version of dplyr, which is the package for data manipulation, we have this kind of new row-wise function, which kind of magically, automatically vectorizes things. So you transform a data frame in such a way that now every operation you perform on it is going to be done on each row individually. The for loop kind of happens behind the scenes automatically for you. And this is the sort of the tension we're always thinking about, like, what's too magical? Like, when does it work? And then, I mean, magic is great when it works, but when it fails, you've got like no idea what went wrong and you've got no idea how to resolve it, versus this tension between like, let's teach you from the ground up, like what a function is, how a function works, what's a higher order function, how does that work, giving you like a very kind of detailed and correct model of the programming language, but now you've got to invest a lot of time into learning it.
Yeah, I really like your summary there, where you say it's a trade-off. On one end of the spectrum, you have total magic, where you're happy if it works, but you don't really know why. And then on the other hand of the spectrum, you have explicitness, where you have to really detail every step you take, which is a lot of work, but then also you have a lot of control. And I think that's a struggle that many people that make software for other people also recognize.
And this sort of comes back to like this idea, like what are the big ideas? Like what are the things that we really believe you have to learn before you can do this stuff correctly and like safely and correctly and efficiently. And we want to keep that as small as possible so you can kind of get into it as quickly as possible, get some wins so you enjoy the process of learning. But at the same time, we don't want to just say like, it's a free-for-all. There's some important like infrastructure, some foundation you need to build up over time so you can, have a good mental model of what's going on and make better decisions in the future.
Yeah, that totally makes sense. Has there been any features that you implemented and then later regretted, where you thought, oh, people don't understand or they misuse this, wasn't the way I wanted people to apply this?
Yeah, so I now have my kind of over time, like my criteria for success of a system has changed. And now one of my criteria for success is that a package is not successful until someone has used it to commit academic fraud. So I think that's the fundamental challenge of like developing general tools. Like if you want people to do like solve new problems with them, you have to accept that they might do things that you think are fundamentally wrong. And there's this sort of trade-off between freedom and safety. And if you constrain people to this sort of like single path where they can only do what you want, that's pretty limiting. And there's lots of things that you didn't think of that might be really important. Generally, like I'm not too worried about that now. I think you just have to accept that people are going to do things that you don't agree with, and you can't kind of control that at the software level. I think the best you can do is to kind of control that at like a social level and, be like a positive role model and show people how to use these tools, ethically and correctly. But you can't kind of put that in at a fundamental level.
Can you give an example of a feature that has been used for academic frauds intentionally or accidentally?
I forget the name of the guy, but he did this pretty study. He sort of faked a bunch of data for his PhD. He got some pretty famous paper out of it and made like these most beautiful graphics using ggplot2. They were like very, very compelling graphics. But really, they're not really like scientific graphics. They're basically propaganda because the underlying data was made up.
Has there been any feature that you had to change?
Yes, a lot of them.
Can you give an example?
That's something we spend a lot of time thinking about now. Like, how do we change things that we've done before? So I think that the arc of tidy data is kind of a good one to talk about that, because I've been working on tools to help you tidy your data, so to go from whatever form you've currently got it into this form that you've got each variable as a column and each row as an observation. And that's something that I've been like working on, I don't know, for like 15 years now. And there've been like four major changes in the way that I think about that. So there've been, over the course of those 15 years, there's been a package called Reshape, another package called Reshape2, another package called Tidier, and most recently, two new functions in Tidier called Pivot Longer and Pivot Wider, which are the sort of the culmination of a bunch of changes, a bunch of feedback over time, people saying like they couldn't understand the functions, or every time they used the function, they had to look up the documentation that just didn't stick in people's head. And so that's something like I find, like that's one of the things that I love like Twitter for, because you can get a stream of things that like people will probably never mention to you in person, but like complain about.
So would you say that's the biggest reason to change a feature, that it's hard to understand for people? Because I think that's what you said there, that you had to change things because people would have to look up the syntax, or they would do it wrongly every time.
Yeah, I think like particularly for what I care about, which is sort of facilitating non-programmers to do data science, to do data analysis in a programming language. Yeah, that's really important. This just wasn't other people either. This was like me as well. Like I would use these functions, which I wrote some time ago, and I couldn't remember how they work. And I would have to read the documentation every time as well. At the time, it made total sense to me. Like I have this experience a lot. Like I'm programming something, I'm like, wow, this is amazing. Like this totally makes sense. This is a great way to think about the problem. And then I come back to it like 3 months later, and I have like literally no idea what I was thinking. And that's very much the experience of like a new programmer, right? They come to this like absolutely fresh. They have few preconceptions, and if it doesn't stick in their brain, I think that can be a sign that there's something wrong with the design of the function.
Yeah, I'd love to hear more about how you gather feedback. So you just mentioned that, people on Twitter, they complain, or maybe they send you compliments of things they like.
Yeah.
I guess you also still use your own tools to do some data analysis. What are other ways that you gather feedback to know the direction of the language?
Yeah, we do like a surprisingly small amount of kind of like quantitative feedback. So relatively recently, we've started doing a few more like very casual surveys, which are mostly like we'll just tweet out a question and point people to a Google form and get sort of feedback on things. Help both in terms of like trying to figure out what are common problems people are facing, and then to try out like, here are 4 possible solutions. Which one of those kind of resonates with you? And this is always a little tricky because we want to try and see what's going to stick in your heads like in 3 months' time, and like measuring that is very, very tricky. The other thing that I think is really hard is people don't know what they need, and it's very difficult to kind of recognize that there's a bunch of like maybe things in disparate areas that if you had one tool or another big idea that help you solve all those problems. Like to me, like that's the thing that we're looking for. Like what are these big ideas? And people don't know what they don't know, and it's very hard to articulate that. I think some of what we do, is just inventing words for new topics, because if you don't have a name for a topic, it's really hard to talk about it. And this, I think, was one of the ideas of like tidy data that's been so impactful, is just having this idea, like this name of tidy data. And you can talk about it, like I'm tidying my data, or my data isn't tidy, this data is tidy. And so how like one of the things that I think is really important is like trying to discover these things that need names. And like I have no idea how to do that really, except to talk to a bunch of different people and try and keep my eyes open for repeated patterns.
Yeah, that's really interesting, because we say you do data analysis, but that's still relatively broad, I can imagine. That probably you have different types of users, like maybe a biologist does data analysis different from a linguist or different from a computer scientist. Is this something you see where different subfields of science have different uses patterns for data analysis and for Tidyverse as well?
So I think there's a huge amount of commonality, particularly at the early phases, which we kind of focus on, like getting the data in, getting it tidied, and doing like a bunch of visualizations so you can figure out what's going on. Like that's hugely similar across fields. That said, people in different fields give all the same things different names and attack things in slightly different ways. But I think at that level, there's a huge amount of commonality. Things tend to get a little bit different, like in terms of the detail, like precisely what visualizations are you going to put on a paper, or what models are you going to use. There's a lot more variation in kind of the customs of an academic field or subfield. But that tends to be something that I don't spend so much time thinking about.
So it is similar enough, like what every scientist does in terms of data analysis is similar enough that you don't need separate packages for being a biologist or a computer scientist.
I think some parts you do, because you're going to deal with like the certain types of data file that only biologists deal with. And, computer scientists, if you're publishing a paper and viz, there are models that people are going to expect that you to use, or that that reviewers are going to understand and it'd be easy to sell on. So certainly there's maybe 20% of the analysis is very specific to a given domain, and every domain needs a bunch of different specialized tools for that. But there is a solid 80% at the heart of it that is the same, that's just about data and working with data, and it doesn't matter what field you're in.
And how does the Tidyverse and R compare to other tools for data analysis? Of course, if I think about data analysis, I think of something like Excel, or maybe in Python you have pandas, which I think shares some of the big ideas of the Tidyverse in terms of data frames and stuff like that, and missing values. So how would you say R compares to alternatives for data analysis?
Yeah, so you kind of identify the two big families of alternatives, which are point-and-click GUIs and other programming languages. I think if you want to call yourself a data scientist, I think one of the distinctions between data science and data analysis generally is that data science is done in a programming language. Because I think programming languages have this kind of immense advantage that they are just text. You represent the sequence of operations you're performing in text. And text is amazingly powerful because you can Google it, you can copy and paste it, you can email, you can turn your problems into something that you can put in an email and send somewhere else. And then of course it's all rerunnable and reproducible. So I think if you are someone who now of course there's a big disadvantage to programming languages. Well, the big advantage of a GUI is kind of everything is spelled out in front of you. You've got all these menus and these buttons, and maybe you can't remember what they all do, but you can kind of search through them. All of your options are laid out in front of you. Whereas with a programming language, you have to remember what you can do and string all the pieces together. So GUIs, I think, are great for casual users, for people who aren't doing data science enough to remember what all the commands are. But I think programming languages for data science are the kind of one of the key distinguishing features of data science.
Yeah, because they're text-based, and that helps you do diffing and storing and reproducibility.
I mean, then
is
copying and pasting from Stack Overflow, one of the most powerful programming techniques.
And it might be, again, this trade-off between explicitness and magic in a certain sense, where a GUI adds lots of magic. It does a lot for you without maybe knowing a lot, whereas in text you can be really explicit, which is nice, for example, for reproducibility perspectives.
Yeah, and then the downside of the GUI too is you're kind of fundamentally constrained by what the author of the GUI wanted to allow you to do. And if you want to break out of that and do something different, it tends to be very, very difficult.
Yeah, then you probably still have to script it yourself using a programming language within a GUI if that is allowed.
Exactly. No, I mean, Excel is kind of an interesting case because it's not just a GUI. It is really a programming language. And I remember when I would have been in high school, that someone showed me a rotating 3D plot that they'd made in Excel, and my mind was just blown. Not using Visual Basic or anything, but just constructing in-cell formulas to do all of the trigonometry to rotate a cloud of points in 3D, and my mind was just blown.
Yeah, it is pretty amazing what you can do with Excel. But indeed, it does suffer from some of the limitations where it's harder to version control, for example. It's harder to email your calculations to someone.
Yeah, I also remember when I briefly taught a class that was R, Excel, and SAS. SAS is one of the kind of older, very specialized programming languages specifically for statistics. And one of the things that I found really interesting is that it was actually quite difficult for me to teach or to show people what I was doing in Excel, because there's a bunch of things where a tiny difference in what you do with a mouse makes a big difference. Are you right-clicking, or are you left-clicking? Are you double-clicking? Sometimes when you're dragging certain things, just being off by a pixel or two gives you a completely different result. That sort of opened my eyes to I'd been a big Excel user for a long time, but just trying to show other people what I was doing was really, really difficult. Whereas with R, I could always copy and paste it and put it into a file that you could run, and you could do exactly the same thing I did on your computer.
Yeah, and given the reproducibility crisis in science, where indeed sometimes it might be people that accidentally just forgot how their spreadsheet works because it was years ago, but sometimes also there's fraud involved, this does seem like a very important feature nowadays.
Yeah, I think the other thing that's sort of interesting, and I guess there's one other style of programming which has its proponents in data science. It's a sort of drag and drop component visual programming style where you like have a bunch of boxes which each represent an operation and you connect them together with lines. And I think like that has like a lot of the weaknesses of programming without having a lot of the strengths. Like you're given this tool that can do anything. You're just creating a graph of arbitrary complexity, but you no longer have all of these tools that programmers have around like diffing and debugging and emailing to people to get their help. I think like that sort of communication side of code is really, really, really important.
I also want to zoom in a little bit about the technical side of R in the Tidyverse. So how does it work technically? Is it like a compiled language or an interpreted language?
So it's an interpreted language, although like as a package developer of R, package developers in general also write under the hood. R is written in C, and so you can also write C code if you want to switch into a language designed for much higher performance. But yeah, R, fundamentally interpreted, kind of interactive language, really designed around the REPL. So you ask a question of your data and get your answer back as quickly as possible.
And if you would write extensions or modules, would you typically then write R modules in R, or do people then fall back to C?
I think the vast majority so in the R community, like we call them packages instead of libraries or modules. So the vast majority of packages are written in R. I think the two main reasons to write them in C is like either performance or because you're connecting to some other pre-existing software or library that's been written in C. So for example, like the R package that works with XML data is basically just a binding to libxml2. So it just provides an interface so the user can write R code that calls C code, that calls a C code written by other people to do all the usual things you want to do to XML.
Yeah, that's an interesting point. That brings me to a next question. Like, how does R interoperate with other systems? You just said, you can load XML data. Can you also embed it with other programming languages? Like, can I have some statistic analysis in R on the front end with JavaScript or something like that?
Yeah, I think so. That really, like historically, like R was this kind of glue language between C and Fortran. And that's, I think, a really big part of R's DNA. This also comes back to your question about kind of performance, that in some ways the point of R is not to be a like really fast programming language, but it should be able to talk to really fast programming languages really easily. So obviously it has like really strong connections to the stuff you want to do for data, for like databases and XML and JSON. And there's really strong connections to C and Fortran from a sort of statistical history. More recently, connections in both directions to Python. Some people have experimented with starting to use Rust to write their high-performance packages. And then, of course, a bunch of connections to JavaScript, mostly from R to JavaScript. One of the things that my colleagues at RStudio worked on is this tool called Shiny, which makes it really easy for an R programmer to basically make a web app, and then all of the JavaScript there's a lot of communication with JavaScript going on behind the scenes.
So then that would allow you to create maybe an interactive visualization on the website based on data analysis done in R.
Yeah, exactly. The other thing we see it used for a lot is kind of this, like historically, if you're producing a report for someone, you would want to make sure you've produced every possible graph that they might ask for. And so you just give them this like 800-page PDF that has every possible graph they might ever ask for, which is obviously not a wonderful user experience. And so now we're seeing people kind of transition to using Shiny apps for that. As a data scientist, you can give the person who needs to understand the data and make decisions based on that, you can give them some kind of like limited analysis ability so they can try out a few different scenarios. They can ask different questions of the data.
So that is the scenario where you have data analysis in R and then you project it to another programming language like JavaScript.
Yeah.
What about the reverse, where you build maybe something like a web app that's collecting data, that's running your experiment, and then can you get your data back into R and run a live data analysis?
Yes. So one of the things that the kind of live data that I'm most familiar with that we use a lot internally is Google Sheets. So we'll collect data like using a Google form, which will go into Google Sheet, or maybe we'll be doing data entry in Google Sheets directly because it's such a like fantastic, like collaborative environment. So we, for example, we're working on RStudio Global, our online conference. This is coming up soon. We in the program committee we use Google Sheets a lot because we can have a live, we can have a meeting, and then three of us are entering data into a Google Sheet, and then we have an R script that pulls that into R, like does some like basic sanity checking, like have we scheduled multiple things at the same time, like have we made one person give 7 talks, or that kind of stuff. And that's just a really nice pattern, this kind of like using like Google Sheets for what it's really good at and using R for what it's really good at, and having this like live update where you can easily see what's happened after you've made some changes to your data.
Yeah, and that's certainly that glue functionality that you talked about before, where R is the glue between something that collects data and someone that wants to look at data.
Absolutely.
So what are your big plans for the future? What features are you working on? What trends are you excited about?
I think generally it feels like we generally have this sort of like punctuated equilibrium, like where we go through periods of like rapid, fairly moderately large change, and then periods where we just kind of like let the dust settle, let people learn about what's changed recently. And it feels like we're coming sort of out of that period of a bunch of change and into a period where we are like consolidating, we're improving our educational materials, we're like making sure we've like smoothed all the sharp corners off all of our functions so they're as easy as possible. And again, this is sort of one of the things that kind of rely on Twitter for, is like just in general, like how is the community like feeling about change right now? Do people want like big new things that they're going to have to learn about, or might make their lives better, but it's going to have to require some investment? Or do they want to stay where they basically are? And I think kind of the message we're getting at the moment, lots of change going on elsewhere in the world, that people basically, I think, are just want to stay where they are and have the rough corners polished down, make everything like fit together a little more tightly, better error messages, fewer error messages, all that kind of stuff.
Are there any features in other programming languages or other IDEs or programming systems that you're like jealous about? You're like, oh, I wish we could also have that, or I wish I had the time to implement that idea into Tidyverse.
And the like very, very kind of big side of things, the things that will take us, if we ever did start on them, will take us multiple years. Like I love the idea of kind of sort of like type inference and bringing in kind of gradual typing in the way that PHP and Ruby and other languages have. So you can start to be a little bit more explicit about what types of data you expect your function to take in and to produce. And that has a bunch of like benefits, from performance to documentation to error messages to testing. That just seems like something I would love, like Haskell has or Rust has to a lesser extent, just stuff like that allow you to make it more explicit and more clear, like what are the inputs and outputs of your function are.
And then do you not implement that because it's too much work, or because it doesn't really fit the language? I can imagine that if you have this missing data type, that makes type inference really hard. If that's allowed, then you need some sort of null type that overarcs all the other types.
Yeah, I think the biggest thing is like there's clearly a large amount of work, and it's not clear exactly what the payoff is. Like I think it would be really cool, but would that actually help enough people to justify, spending probably 2 or 3 programmer years worth of work on it? And, this in general is my personal challenges. There's lots of like really cool programming things that I love and think are really awesome and amazing and would be fascinating to explore in more detail. But I'm not sure whether anyone else would really care about them that much, or whether they'd actually have a positive impact on most people's lives.
Yeah, that is hard to know, of course. If a new feature really makes something better, like you just had better error messages, like what is better? Like more detail might help some programmers, but might actually harm the productivity of other developers, because then they have to read the entire error message, which might not be so useful. So how do you know if a new language feature is better? Is it just gut feeling? Because you said before that you didn't really do any detailed surveys.
Yeah, I mean, it's mostly, I think it's like a combination of gut feeling, like sort of trying it out and then seeing how it feels to us as like data analysts. And then, just talking it, like bringing it to the community and kind of saying like, how does this like feel to you? But it's a really, really, even if we did kind of invest significantly, it's not clear to me like how you even measure the things that we care about. At least I realize like one metric that I care about is kind of time spent in flow state. Like I think in some ways that's the key metric I would love to optimize. Like I want you to be in flow state where you are like getting code out of your brain. Your fingers are just like typing R code. You have to think about it relatively little. You're fluent. You're not searching your brain. Like that's kind of what I want to optimize. But like, how on earth do you measure that? And then how do you kind of like measure? It's not just like in the moment. It's like combination of how long it takes to learn it all and to get into that place where you can do this. It's really, really, really hard.
Yeah, this is what sometimes programming language designers call like the language gets out of the way. You just allow the user to program and the language isn't giving you annoying pop-ups like, oh, this type doesn't match what you're doing here.
Yeah.
It's almost like the programming language isn't there and you can just express your thoughts directly. But that is really hard to acquire, of course, in a programming language.
Yeah, but there's also at the same time, like the programming language also has to like help shape your thinking in a way that kind of guides you naturally towards a path that's more likely to be successful. And again, I just have like I mean, how you do that is really, really tough. It does really feel like a kind of an art or a craft, not a science right now.
Yeah, and it does seem, even though you say that you don't really know how to do it, it does seem like you're doing really well because the Tidyverse is a really popular R package and it has supported many statisticians and also other scientists over the years in doing lots of data analysis.
Yeah, I mean, I think we've been like pretty successful. I think we managed to do quite a good job. Like, I don't know how we do it. I think we've done it enough successfully that doesn't seem to be, it's not just luck. But I don't know exactly what it is that, like, how we think about this problem. Like, what are the skills we bring to bear that are really the most useful?
Yeah, it might be a combination of experience. You have scientists yourself, really doing a PhD, doing data analysis, and then getting to know the problem space really well, and then designing something. That does seem to be key, I think.
Yeah, the other thing that's interesting to me as I kind of get more senior in age is as sort of new folks join my team, it's clear like there's people on my team and in the community and in the world whose kind of raw programming power is much like greater than mine. They can churn out code much faster than I can. But somehow I have this like ability, the skill that I have is seeing like 2 or 3 steps down the road and being like, oh, these 2 different things are going to have this kind of conflict. You're going to run into problems in like a month's time if you continue down this path. And that's just it's sort of interesting to see like where your skills are when you work closely with other people who are like very, very, very talented.
Yeah, and I would say that's probably due to your experience in working with these types of systems and having developed them, that you don't need to be the most efficient programmer. But if you can indeed envision what features people might like, how they might combine together, then that is very interesting.
Yeah, which is not to say I don't still spend a lot of time on dead ends and writing a bunch of code that I eventually throw out. But I think that's the other thing I've become more comfortable with over time is just accepting that like creating something good is often about like throwing out things that you've spent potentially a lot of time on, whether that's like code or writing, or I think even like baking, like the way that people present like these beautiful trays of cookies is that there's also like another tray of really ugly cookies that you never get to see.
Yeah, and probably also like 100 trays of cookies in their past that they baked that were only just a little bit happy about.
Yeah, exactly. And it's very like you can't see that. Like it's very hard to see that from the outside. You look at someone and you see all of the things that they've been successful at and presented to the public. You don't see all the things that they've tried and experimented that did not succeed.
Yeah, that's true. Hey, if that was all I wanted to ask, is there anything that we missed? Anything where you say, oh, I really want to share this and this fact about the Tidyverse?
I don't think so. I mean, the main thing is if you're kind of interested in learning more, and Tidyverse has a website. of course. And there's also a book that I co-wrote with Garrett Grohlman called R for Data Science, which is like really our attempts to take someone potentially who hasn't programmed at all and help them become competent, happy data scientist in R. So that's available online for free. You can just Google R for Data Science and get the details there.
Yeah, we'll put the link to R and the Tidyverse and also to your book in the show notes so people can easily find them. Is there anywhere else we can find you on the web? Are you on Twitter? Do you blog?
Yeah, Twitter. I'm mostly on Twitter. I spend probably too much time on Twitter. It's just at Hadley Wickham. I don't have a personal blog, but we have a team Tidyverse blog. That's at tidyverse.org. That's the best place. Yeah, I think that's mostly of interest if you use the Tidyverse because that's where we post all the release announcements. That's where we kind of post important, like, hey, we're thinking about making this really big change. Like, please give us feedback kind of thing. So I think that's a great place to hang out if you're familiar, if you use the Tidyverse frequently.
Great. So we'll make sure that we will also link to the Tidyverse blog and to your Twitter account in the show notes. Thank you so much for being on the show, Hadley.
Well, thanks, Felienne. Thanks for having me.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.